Today's lesson: atomic size along a column and along a period. That is, change of atomic sizes along a column and along a period. We all are well acquainted with periodic table, wherein there are 118 elements. These 118 elements have been placed in periodic table in 18 columns and 7 periods. These 118 elements have been placed in 18 columns and 7 periods. Atomic sizes change along a column and along a period. What is the fashion of change and what is the reason behind this? This is today's lesson. So let's go to the detail. For example, let us take one column and one period from the periodic table. Column 1 and period 3. The elements are column 1, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. These are the elements that belong to column 1, and elements in the third period are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. These are the elements that belong to third period. What is the fashion of change of atomic sizes? Let's see along a column and along a period. Along a column, atomic sizes increase from top to bottom, and along a period, atomic sizes decrease from left to right. That is, along a column from top to bottom, atomic sizes increase, and along a period from left to right, atomic sizes decrease. What is the reason behind this? First of all, let's see change of atomic sizes along a column. Let's write elements that belong to column 1. Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Atomic number of hydrogen is 1, lithium 3, sodium 11, potassium 19, rubidium 37, cesium 55, francium 87. We learned that atomic sizes increase from top to bottom. Let's see the reason. Here, electronic configuration of hydrogen is 1s1. That is, nucleus of hydrogen. It has just one shell that contains one electron. Then electronic configuration of lithium, atomic number 3. Electronic configuration is 1s2, 2s1. That is, this is the nucleus. First shell contains 2 electrons, and it has another shell that contains 1 electron. Now let's see electronic configuration of sodium. Atomic number 11. 1s2, 2s2, 2p6, 3s1. That is sodium nucleus. First shell contains 2 electrons. Second shell contains 8 electrons. And third shell contains 1 electron. That is, from top to bottom, in each case, one new shell is added to the outermost shell. Now let's see electronic configuration of potassium. Potassium 19. 1s2, 2s2, 2p6, 3s2, 3p6, then 4s1. That is nucleus. First shell contains 2 electrons. Second shell contains 8 electrons. Third shell contains 8 electrons, and it has another shell, that is fourth shell, that contains 1 electron. It is clear that from top to bottom, in each case, one new shell is added. That is why from top to bottom along a column, atomic sizes increase with the increase of atomic number. Let's clarify one point, that is, from top to bottom along a column, atomic numbers increase. That is 1, 3, 11, like this. Here, in case of hydrogen, 1 proton and 1 electron. The attraction between 1 proton and 1 electron. Attraction between nucleus and outermost shell electron. In case of lithium, 3 proton and outermost shell 1 electron. In case of sodium, 11 proton, outermost shell 1 electron. In case of potassium, 19 proton and outermost shell 1 electron. This is the attraction. Attraction between nucleus and outermost shell electron. Here, the attraction between nucleus and outermost shell electron is shielded by inner shell electrons, which is known as shielding effect. Due to the shielding effect, though atomic number increases, that is, number of protons increases in the nucleus, it cannot contract the outermost shell, because the attraction between nucleus and outermost shell electron is shielded by inner shell electrons, which is known as shielding effect. So, along a column, due to the shielding effect, increase of atomic number is not effective. Only here, new shell is added in each case, it becomes effective. That is why along a column, from top to bottom, atomic sizes increase due to the new shell added in each case. Now let's see change of atomic sizes along a period. Let's write elements that belong to period 3. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Atomic number of sodium is 11, magnesium 12, aluminium 13, 14 for silicon, 15 for phosphorus, this is 16, 17 and 18 for argon. Let's see electronic configurations of these elements. Sodium 1s2, 2s2, 2p6, 3s1. Atomic size is first shell contains 2 electrons, second shell 8 electrons, third shell 1 electron. Now let's see electronic configuration of magnesium. 1s2, 2s2, 2p6, 3s2. That is here first shell 2 electrons, second shell 8 electrons, third shell 2 electrons. Now let's see electronic configuration of, suppose, chlorine. Chlorine 17, 1s2, 2s2, 2p6, 3s2, now 3p5. That is for chlorine, first shell contains 2 electrons, second shell contains 8 electrons and third shell contains 7 electrons. That is, along a period, shell number is not changed. In each case, number of shells is same. For the third period, this is 3 shells. So, along a period, atomic size should be same, like this, because in each case number of shells is same. No new shell is added. That happens along column. So along a period, atomic sizes should be same, but not same. It decreases like this. What is the reason behind this? Here, in case of sodium, nucleus contains 11 protons and outermost shell contains 1 electron. In case of sodium, attraction between 11 protons and 1 electron. But in case of magnesium, magnesium contains 12 protons and in the outermost shell there are 2 electrons. In case of magnesium, the attraction between 12 protons and 2 electrons. So here the attraction for sodium, which will be lowered than magnesium, because here attraction between 11 protons and 1 electron, and for magnesium this is 12 protons and 2 electrons. So in this case, because of the greater attraction, the outermost shell contracts. That is why magnesium atom is a bit smaller than sodium. Similarly, if we go to the chlorine, in case of chlorine we see atomic number of chlorine is 17. So here 17 protons that attracts outermost shell electrons. In case of chlorine, outermost shell contains 7 electrons. So here attraction between 17 protons and 7 electrons. So here the attraction is higher. That is why outermost shell contracts greater than other elements like sodium, magnesium, aluminum. That is, if we go from left to right, attraction between nucleus and outermost shell increases with the increase of atomic number. Here, no shielding effect, or shielding effect is same, because inner shell electrons same. For the third period, this is 10 electrons. So along a period, same shielding effect. Shielding effect here is not effective. Only attraction between nucleus and outermost shell is effective. And along a period, this attraction between nucleus and outermost shell increases with the increase of atomic number. For this reason, from left to right, atomic sizes decrease due to the increased attraction between nucleus and outermost shell with the increase of atomic number. Now let's conclude. Atomic sizes increase from top to bottom along a column, and it decreases from left to right along a period. This is all about atomic sizes along a column and along a period. If this lesson benefits you a bit, please subscribe to the channel. No more today. Thank you very much.